This is a short podcast on Hess's law. Hess's law involves the additivity of reaction heats. Essentially what we can do is calculate the enthalpy of a particular reaction if we have reactions that can be used to create that equation. For example, we have carbon plus 2 oxygen atoms to make carbon dioxide. Well, the 2 oxygen atoms making oxygen gas can be used, and the delta H there is negative 250. We have kept the oxygen atoms on the reactant side where they are. Now, the carbon is in this particular one as a gas. So in order to get it to a gas, we have to take the carbon solid to carbon gas reaction and reverse it. And the positive 720 becomes negative 720 kilojoules. You do the same thing with the carbon dioxide we wanted on the product side. And so again, we reverse that heat value as well. Then, when you cancel the compounds, the 2 carbon solids cancel, the 2 oxygens cancel. When we add the reaction together, we get a value of negative 1,360 kilojoules for the reaction of carbon as a gas reacting with oxygen atoms to make carbon dioxide. Similarly, we could calculate heat of combustion for magnesium. We need solid magnesium on the reactant side, and so we take the first equation and use it as is. Magnesium oxide is the product, so we're going to take the second equation, but once again we have to reverse it. And so that the negative 113 kilojoules becomes positive 113 kilojoules. Then, in order to cancel things, we have to introduce the H2 plus a half O2, H2O. That itself is also at negative 286 kilojoules per mole. The hydrogens will cancel on either side. The waters cancel on either side, the magnesium chlorides cancel on either side, and finally the hydrochloric acids cancel on either side. And then when you add them up, you get a value of negative 602 kilojoules per mole for the heat of combustion of magnesium. And that is a second example of the use of Hess's law to calculate the heat of a reaction.